Good morning, afternoon, or evening, cats and dogs. We're going to be working on lesson 5.2, and this really incorporates this entire set of guided notes, lessons 5.1, 5.2, and 5.3 from our next unit. This is unit 6 we're working on, chapter 5, information. So let's start off with some key definitions. The first one is the word ratio, and a ratio is a comparison of two or more quantities by division. We can write ratios in multiple ways. We can use a colon, we can use the word to, or we could use the phrase out of. So as we go into our examples down below, we're going to see the phrase out of used, we're going to see the colon, and we're going to see the word to also being used. There's different ways to write ratios. And I do want to point out ratios are something you will see often in real life. If you're looking at your odds of winning the lottery, for example, or a lot of times during the holidays, people get scratch-off tickets. A lot of times on those lottery tickets, or at least online, will be your odds of winning or your odds of winning a certain amount. So those are usually written as ratios with a colon. We can write a ratio of two things as a fraction in simplest form. So we're going to talk about two main topics in this video for the first part of our guided notes. The first of those is writing ratios as fractions in simplest form. Now, when we write ratios as fractions in simplest form, there's a couple of things that are really important for us. First of all, it is not in simplest form if you have any decimals in the numerator or denominator. So no decimal is allowed to remain in either the numerator or denominator. That's really important for us. Otherwise, the fraction is not in simplest form. I will sometimes have students who write like 3.5 over 7. That is not a fraction in simplest form. We'll talk about how to deal with that. My calculator will give me an error message if I try to plug in 3.5 over 7. So we'll show you how we can deal with that situation if it comes up. When writing a ratio using measurements, both quantities should have the same unit of measure. This is bolded, but I'm also going to highlight this in green. And example 2 really shows this nicely for us, and we're going to see some examples mixed into the problems. But if I have something like 3 inches to 5 feet, a lot of times students will write their answer as 3/5. This problem, though, involves measurements, and they need to be the same unit of measure in order for us to write it as a fraction in simplest form. So I rewrite your larger unit of measure, in this case 5 feet, in terms of inches. Well, I know that there's 12 inches in a foot. 12 times 5 is 60 inches. So 5 feet, I'm going to highlight this in blue, is equivalent to 60 inches. So I replace 5 feet with 60 inches. Now we do have the same unit of measure, so I can cross these labels off. 3/60 reduces to 1/20. So 1/20 is the correct solution there. Again, 3/5 is not correct. If it involves units of measure and you can make them the same unit of measure, do that first. So a couple of really important points here. One of the questions I get from students a lot is, what if I don't know the conversions? You do have them provided in the guided notes. It's also something that I will provide you for on a quiz, or provide you with on a quiz or a test. So let's look at some examples down below. We've got 9 of these to start with. So let's look at numbers 1 through 3. Our examples ask us to write each ratio as a fraction in simplest form. So if I have 34 points out of 98 points, they're not units of measure. I just put 34 points over 98 points and I simplify. My calculator does that for me. I just put in the fraction, I hit equals, and it will simplify it to 17/49. Please make sure you practice this to see that your calculator does simplify fractions for you. Sometimes weird things happen, and we just need to talk about how to deal with that if that happens on your calculator. Now, number 2, this is the third thing that's kind of weird in this part. There's a lot of like little things in this unit that are really important to pay attention to. So I have 87 oranges to 33 oranges. The first number goes on top, 87. The second number goes on the bottom, that's 33. But if I plug this into my calculator is going to get me 2 7/11. It doesn't mean my calculator is wrong, but we want to, go ahead and type that in there. We want to leave improper fractions as improper fractions because we are writing the ratio of one number to another. So if this is what my calculator gives me, all I need to do is take 11 times 2 to get 22, add on 7 to get 29, keep the same denominator of 11. Some of your calculators might have a button that will transfer between mixed numbers and improper fractions. But again, if it gets me this, I take my denominator times my whole number plus my numerator, keep the same denominator. This is going to happen on number 3. So we have 72 cards over 30 cards. We can cross off the cards. And then I did show the work to reduce it. I'm going to highlight this in yellow here. You don't need to show this work. But this shows us how we can simplify this if we do not have a calculator handy to work through this. Excuse me while I grab a drink. I had a little tickle in my throat there for a moment. So if we have a calculator, though, our calculators will simplify this. Excuse me. It will get me 2 2/5. I swear I'm not sick. It's just a little tickle I got in my throat all of a sudden. So we get 2 2/5 for this. And then we do want to write that as an improper fraction. And I'll show you how to do this. So let me just type this in for us. We'll take 5 times 2 to get 10. 10 plus 2 is 12. Keep the same denominator of 5. So we get 12/5. Again, you don't have to show this work. Your calculator will automatically, at the very least, take you to 2 2/5, which we can then write as an improper fraction. So a couple of really important things here, just to summarize, is first of all, put the first number on top, second number on the bottom. No decimals allowed in the numerator or denominator. If we have measurements, which we're going to see in a few moments, we want them to have the same unit of measure. And again, we want to keep improper fractions as improper fractions because we're comparing two different things. All right, let's look at some more practice. So these next 3 that we're going to see involve measurements, and I think there's one more of these also. So if I have 8 inches to 5 feet, put 8 inches on top, 5 feet on the bottom. But since I know 5 feet is 60 inches, I'm going to replace the 5 feet with 60 inches. So I have 8 inches, now over 60 inches, reduce that to 2/15. You don't need to put any labels on your solutions, but you do want to make sure that you have common measurements when you simplify it. Number 5, we have 1 ton to 45 pounds. So if we know that 1 ton is 2,000 pounds, replace 1 ton with 2,000 pounds. Now simplify this. It's probably going to give you a mixed number. I don't recall what it is off the top of my head, but you do end up getting 400/9 when you write it as an improper fraction. Definitely important for us. All right, number 6, we have 2 miles to 14 yards. So start by writing it as 2 miles to 14 yards. We do, however, want to, and I'm just going to pull all of this down, we want to take our larger measurement, in this case miles, and rewrite it in terms of yards. So you're going to see that I have 3,520 yards here. You might wonder where that comes from. Well, in our miles, we have to know that there's 1,760 yards in 1 mile. So if we're talking about 2 miles, we're going to multiply by 2. That's where the 3,520 yards comes from. So 1,760 yards in a mile. Since we're looking at 2 miles, we will replace 2 miles with 3,520 yards. You don't have to memorize that conversion. It's in the notes, and again, I will provide it for you. So this is what I have. I plug 3,520 over 14 into my calculator. It gives me this as the solution. I'll highlight it in green. 251 3/7. So what I do is take 7 times 251 plus 3. It's going to get me 1,760. Keep my denominator of 7. Now you could also try to simplify this sort of, I say by hand, but you could still use your calculator to divide both 3,520 and 14 by 2. But again, the important thing here is not only just making sure your units of measure are the same, but then keeping improper fractions as improper fractions. Let's look at another one, number 7. 9 quarts to 5 gallons. Start with that. Gallons are bigger than quarts, and there are 4 quarts in a gallon. So I would take 5 times 4 to get 20. So replace 5 gallons with 20 quarts. 5 times 4 is 20. We get a solution of 9/20. And again, my work is down below just to convert 5 gallons into 20 quarts. You don't necessarily have to show that work, but we end up just getting 9/20. That does not reduce or simplify at all. Now our last thing is that decimal. I do want you to practice plugging this into your calculators. So if I have $1.20 to $3, you can put $1.20 on the top, 3 on the bottom. Try doing that in your calculator, 1.2 over 3. Some calculators are going to give you an error message. Mine does. It says syntax error. Some might give you 0.4, which you would then have to convert into a fraction. That's 4/10, which is 2/5. But one option you have, and pay attention to this even if your calculator gives you 2/5, move the decimal point to the right in 1.2 one space to get 12. But you have to move the decimal point in the 3 to the right one space as well, adding a 0 to get 30. So whatever you do to the top, you also have to do to the bottom. If you put 12/30 in your calculator, it should simplify to 2/5. Let's try number 9. Start off by writing 13.5 miles over 30 miles. Thank goodness they're already common units of measure. Move your decimal point to the right one place in both the top and bottom. Will get us 135 over 300. Reduce that. Now again, you do not need to do any work to show your solution. But if we reduce it or put 135 out of 300 in our calculators, it will simplify to 9/20. So again, a few important points as I give you a chance to try a few on your own. One, in problems like number 1 here, you just put the first number on the top, second number on the bottom, and simplify. For problems like 2, where your top number is bigger, keep in mind we want to keep improper fractions improper. For problems like number 3, we want to make sure they're the same units of measure before we start and then simplify. And for problems like number 4, we might need to get rid of the decimal point before we go to simplify it, because again, we can't leave any decimal points in our final solution. Go ahead and pause the video, give numbers 1 through 4 a try, and when you're ready, restart the video and we'll take a look at these 4. All right, hopefully you've taken a look at these. So number 1, we've got 14 points out of 48 points. It reduces to 7/24. No need to show any work there. 45 apples to 30 apples. Start with 45 over 30, reduce it, it reduces to 3/2. Again, we don't want to write it as 1/2. We want to keep it as an improper fraction. 9 inches to 3 feet is not 3. We want to rewrite or replace 3 feet as 36 inches, since there are 12 inches in a foot. 36 inches and 3 feet. So 9/36 reduces to 1/4. And then finally, number 4, I do have to move the decimal point to the right one spot. I've got 20.5 out of 50. We can cross off the miles as well. I didn't show that here, but we could. 205 over 500 once you move the decimal point to the right one place. And we end up getting 41/100. All right, let's talk about our other topic, which is rates and unit rates. Last thing to talk about in this video. So a rate is a ratio of two quantities having different kinds of units, miles and gallons, dollars and boxes, for example. But I want to spend most of our time talking about unit rates, which is what we see a lot in real life. It's when a rate is simplified so that it has a denominator of 1. Unit means 1. In most cases, you will divide the first number by the second number. In fact, all of the examples today, we will do that. You will want to make sure you put a label on your solution, like dollars per pound, miles per hour, feet per second. You use the label of the first number that you divided, followed by the word per or a slash, and then the label of the second number. You always want to think, does my label make sense? So if it took you 5 hours to drive 325 miles, it wouldn't make sense to take 5 divided by 325 because that actually gets you the number of hours per mile. We don't want that. We want to know how many miles per hour you're traveling. So instead, take 325 miles divided by 5 hours to get 65 miles per hour. Definitely important for us here. Again, just a lot of little things mixed in. Sometimes I have students who assume, well, we have to take the bigger number divided by the smaller number. That's not always the case either. Just divide in the order that makes sense. The directions will ask us to either round to the nearest tenth, which means one number after the decimal point, or sometimes when it deals with money, it might ask you to round to the nearest cent. So anytime you are dealing with money or the cost of an item, you will round to the nearest cent, which means rounding to the nearest hundredth, 2 numbers after the decimal point. So there's a lot of little things here. Dividing in the right order, putting the correct label, and rounding appropriately. So let's look at number 10. We'll look at numbers 10 through 19. Express each ratio as a unit rate. Round to the nearest tenth or nearest cent if needed. So number 10, if I want to find the cost per ticket, that's my unit rate. I'm going to take the cost of $58 divided by the number of tickets we purchased, which is 5. My calculator gives me 11.6. Since this is a money amount, I will write it as $11.60 per ticket. And number 11, which means adding a 0 to the end, I've got $4.19 for 4 cans of soup. So I want to find the cost per can. We are going to take $4.19 divided by 4 cans. I do like to put my labels on my work as well. That way I don't forget to put my label on my final solution. My calculator gives me 1.0475. So I need 2 numbers after the decimal point. So I visit the neighbor immediately to the right, which is 7. And if that digit is 5 or higher, it's a 7. Then I'm going to round the 4 up. 4 or smaller, I keep it the same. So this will be $1.05 per can. All right, let's take a look at number 12. It costs $274.90 for 6 people. I want to find the cost per person, so I'm going to take $274.90 divided by 6 people. I get exactly 45.816 with the 6 repeating. I need 2 numbers after the decimal point, so I'll visit the guide next to the 1, which is a 6. 5 or higher, I round up, so that means that, again, I'm paying attention to this digit right here. My 1 is going to go up by 1 and become a 2. So I get $45.82 per person. Number 13, I want to figure out how many miles per hour we're traveling. So take 565 miles divided by 12 hours. We get 47.083 repeating. This is one where it's probably a good idea to round to the nearest tenth. So I go to the tens place, which is a 0. The neighbor next door is an 8, so I'm going to round the 0 up to a 1. So if I round to the nearest tenth, I'll get 47.1 miles per hour. Don't forget your labels. Again, I can put MPH here. That's one we see pretty often, but it's always going to be something per something, not just 47.1 miles. If you say 47.1 miles in 1 hour, that's okay too. But labels really matter. It shows me that you truly understand it as well. Number 14, it's $9 for 6 cans of soup. We want to find the cost per can. So let's take $9 divided by 6 cans. My calculator gives me 1.5. That is $1.50 per can. Number 15, 51 meters in 8 seconds. Take 51 meters divided by 8 seconds. My calculator will give me 6.375 meters per second. You can abbreviate meters with an M, seconds as either S or SEC. If you want to round to the nearest tenth, 6.4 is also acceptable. The directions say if needed. I would argue that if it's a short decimal like this, maybe it's not necessary, but you certainly can. Number 16, last 4, 21 new pairs of sneakers in 7 years. So we want to find how many new pairs of sneakers per year. Take 21 divided by 7. Clearly going to be 3 new pairs of sneakers per year. Number 17, 40 sneezes in 20 minutes. So for this, I want to figure out how many sneezes per minute. So we'll take 40 divided by 20, and that will get us 2 sneezes per minute. All right, last 2. Number 18, 108 miles in 6 days. We're going to take 108 miles divided by 6 days. We will get 18 miles per day. Don't forget that label. Number 19, $2,702 from 28 people. Find the cost per person by taking 2,702 divided by 28. My calculator gives me 96.5, but I will write that as $96.50 per person. All right, I do have some independent practice for you guys to try. So pause the video, give these 4 questions a try, and we'll take a look at them in just a moment. All right, hopefully you've taken a look at these 4 questions. And number 1, $183 for 4 concert tickets. Take 183 divided by 4. We should get $45.75 per ticket. So I'll type this in. Let me change the color here. There we go. So we've got $45.75 per ticket. We'll make this. There we go. Taking a look at number 2, we've got 254.1 miles on 10.5 gallons. Take 254.1 divided by 10.5, and we get exactly 24.2 miles per gallon. The abbreviation you can use for miles per gallon is just MPG. You might see it if you've ever gone to a car lot and looked at new cars or even used cars. They often have the gas mileage listed on them. Our next one, $31.60 for 8 pounds. Take $31.60 divided by 8. You will get $3.95 per pound. One option you have is to use a slash and then abbreviate pounds as LB. This is something you see really often at the grocery store if you go to a market or something like that. You'll see a unit rate as a cost per pound. Our last one, number 4, take 576 divided by 9. We will get 64 miles. Let me just double check that. Yeah, we will get 64 miles per hour. I don't know why that didn't stick in my head from before, but 64 miles per hour, feel free to abbreviate that as mph. So while most of this information is pretty easy, there's a lot of little tiny things to remember and keep in mind. So we'll continue to review those throughout this unit and see them repeatedly.
Number 20, it says, which is the best buy? Show your work to justify your answer. We have 6 shirts for $25.50, 4 shirts for $18, and 5 shirts for $21. If we want to figure out which is the best buy, we want to figure out which one has the lowest cost per shirt. So when we divide, we want to make sure that we take the cost and divide it by the number of shirts. So for example, if I want to find the cost per shirt for our first example, 6 shirts for $25.50, I'm going to take $25.50 and divide it by 6 shirts. That will get me a cost per shirt of $4.25 per shirt. Try the 4 shirts for $18 and the 5 shirts for $21. Okay, hopefully you've at least tried the first one, the 4 shirts for $18. So we want to take $18 divided by 4 shirts. That will get us a cost of $4.50 per shirt, so a little bit more expensive per shirt. For the 5 shirts for $21, let's take $21 divided by 5 shirts. That will get us $4.20 per shirt. So if we're looking for the one that is the best price, the best buy in this case, we are looking at the 5 shirts for $21. I often have students who want to tell me that the 6 shirts for $25.50 is better because you're getting 6 shirts for just a little bit more. But again, you are paying more per shirt. It's only a difference of 5 cents. Although between the 5 shirts and the 4 shirts, you're looking at a 30-cent difference between the shirts, or price per shirt, I should say. But again, we are looking at a lower price per shirt for the 5 shirts for $21, making it the best buy. All right, number 21. This is a really good question. I think you have a similar question to this on your test or at least on some sort of assessment. So let's take a look at it. Number 21, it says, at the grocery store, an 8-ounce jar of Nutella costs $6.25. A, find the unit price of a jar of Nutella, which means we want to find the cost per jar. So that means we need to take our cost, which in this case is $6.25, and divide it by the number of jar, or the amount of ounces in the jar, which is 8 ounces. So let's take $6.25 divided by 8 ounces, and we get $0.78125 per ounce. Now notice how it says not to round here. If I were to round, this would be about 78 cents per ounce, but because I'm going to use my answer from part A to help me figure out part B, I'm not going to round it. So in part B, if I want to find the cost of a larger jar of Nutella, that's from Mrs. Garcia, 26.5-ounce jar of Nutella, well, I know the cost per ounce from part A, so what could I do to find the cost of a 26.5-ounce jar or any size jar of Nutella? If you're thinking to multiply, you're correct. So let's take the 0.78125 times the 26.5. And that gets us exactly 20.703125. Now this we do want to round to the nearest cent since it's our final solution. So that'd be $20.70. Again, I go 3 digits after the decimal point. If that number is a 5 or higher, we'll round the 0 up. But in this case, it's 4 or smaller, so we leave the 0 the same. And it would be $20.70. All right, let's move ahead to question number 22, an error analysis question. Which costs more per ounce, 240 ounces for $19.20 or 64 ounces for $4.48? We can see Lisa's work down below, and she says that 64 ounces for $4.48 costs more per ounce, since when she did her calculations, she found that the 240 was $12.50 per ounce, according to her work, and the 64 ounces was about $14.29 per ounce. What mistake did Lisa make, and how could she correct her mistake? Take a moment and think about this. So let's keep in mind that she wants to find the cost per ounce. and that's not what she found here. She took the number of ounces divided by the cost. So technically, yes, this is 12.5, but it's not $12.50 per ounce. It's actually 12.5 ounces per dollar. So in this situation, you get 12.5 ounces per dollar. In this situation, you'd get about 14.3 ounces per dollar. So you'd actually get a little bit more per dollar in this case, and this one would actually cost a little bit more per ounce, or would be the pricier option. What she really should do is she should take the cost divided by the number of ounces instead. So it says, since Lisa is trying to find the cost per ounce, she should divide the cost by the number of ounces. She divided the number of ounces by the cost, which is not correct in this case. She can correct her mistake by doing $19.20 divided by 240 ounces and $4.48 divided by 64 ounces. And that would tell her which one has the higher cost per ounce. In this case, we're actually asking for the one that has a higher cost per ounce. We don't actually have to correct the mistake and do it correctly, but it would switch around which one costs more per ounce. All right, let's talk about our next topic, which is identifying unit rates from graphs. So it says to identify the unit rate from each of the following graphs, put a label on your answer. Keep in mind a unit rate is something like miles per hour, feet per second, dollars per hour. So if I'm looking at question number 23, I want to figure out, we're looking at the number of miles traveled over a certain number of hours. So I want to figure out how many miles per hour. So how many miles in 1 hour. So when I'm talking about this, I want to look for 1 hour and follow it up until it hits my graph, which is going to happen here, and then follow that across. So this point right here on my graph is going to represent my unit rate. And we're looking at halfway between 25 and 75, which is going to be at 50. So this ordered pair right here is 1 comma 50. Oops, if I could type. It's 1 comma 50. That means my unit rate is 50. And in this case, it's 50 miles per hour. So 50 miles in 1 hour. Taking a look at number 24, let's do the same thing. We're looking at Sarah's earnings over a certain number of hours. So we're trying to figure out how many dollars per hour she earns. So let's go to 1 hour and follow it up until it hits my graph, and then follow it across. This point right here is going to represent my unit rate. The problem with this is I'm not really sure where this is. I know it's going to be 1 comma something, but I don't know what that something is exactly. It looks to be halfway between 20 and 25. What I can do is I can go up to this dot, which is on my graph. This dot right here is 2 comma halfway between 40 and 50, which is 45. So 2 hours, she earns $45. If I want to figure out my unit rate, I can take $45 and divide it by 2 hours. And that will get me $22.50 per hour, my unit rate. So that actually happens to be what this question mark is here. And that's what we thought was halfway between 20 and 25. But now we know for sure, since we have a constant rate, we have a straight line going on here. So this is 22.50 or 22.5, which means our unit rate is $22.50 per hour. Again, we might need to use some of the other things on the graph to help us determine for sure where that unit rate is. All right, let's take a look at number 25. So we're looking at a family road trip, the number of miles they traveled over a certain number of hours. So we're looking for the number of miles per hour. So here's 1 hour. Let's follow it up. Let's follow it across. This point right here is going to represent my unit rate, and that is at 1 comma 60. So my unit rate is going to be 60 miles per hour. Pretty easy to identify unit rates from a graph. Let's take a look at number 26. We're looking at the amount of water consumed in liters over a certain number of days. So we want to figure out how many liters per day or in 1 day. So follow the 1 up. Remember, unit means 1, so that helps us. This point is going to represent our unit rate right here. There's already a dot there, which is really nice for us. Let's follow this across. This is the ordered pair 1 comma 10. So that's 10 liters per day. And that is our unit rate. So our next topic is complex fractions. This question I get from students a lot is, are we allowed to have fractions in the numerator or denominator of a fraction? And you are. It does mean, though, that the fraction isn't in simplest form. So complex fractions are fractions with one or more fractions in the numerator, denominator, or both. Complex fractions are simplified when both the numerator and denominator are integers. There should not be any decimals or fractions left in the numerator or denominator for a fraction to be in simplest form. So we're going to allow you to use calculators in this unit, but I'll show you some examples without a calculator. So if I have something like 1/3 over 1/2, and I want to simplify that, keep in mind a fraction bar represents division. So I could actually write this as the numerator 1/3 divided by the denominator 1/2. If you recall back to when we multiplied and divided fractions, we do the keep change flip here. So we can rewrite this as 1/3 times 2 over 1, and that will get us 2/3. The same way with 1/4 over 2, I can write that as 1/4 divided by 2 and do 1/4 times 1 over 2, keep change flip. That will get us 1/8. Now, if you want to use your calculators for this, you simply just type in 1/4 divided by 2 or 1/3 divided by 1/2. Some calculators will allow you to put a fraction in a fraction and simplify. A lot of the calculators, though, like the ones I have in my classroom, will not. So that's why we talk about this. So number 27, if I have 1/2 over 3, I can rewrite that as 1/2 divided by 3, which is 1/2 times 1/3 or 1/6. But again, you can plug it into your calculator as 1/2 divided by 3, and it will automatically give you 1/6. Number 28, we have 1/2 over 1/4. So write it as 1/2 divided by 1/4. Keep change flip is 1/2 times 4 over 1. Gets us 4 over 2, which is just 2. Number 29, 1 over 1/5. Do 1 divided by 1/5. Keep change flip is 1 times 5, which is just 5. Works out really nicely for us. Now, our last one I didn't bother to rewrite mixed numbers as improper fractions. I just used my calculator for this. We've got 4 and 1/2 divided by 2 and 7/10. Just plug that into your calculator. What do we get? Hopefully you got 1 and 2/3. Keep in mind, if you divide in the wrong order, you will get the reciprocal of the answer. So instead of getting 1 and 2/3, you might end up getting, let's see, 3/5 for your solution. So be careful as you plug them into your calculator. All right, let's talk about some word problems related to unit rates and even complex fractions. So when the fractions of a complex fraction represent different units, you can find the unit rate. We've already done this, so a lot of the things in this unit are going to continually overlap, which is good for us. In number 31, it says Brian can run 2 and 2/3 miles in a half hour. Find his average speed in miles per hour. So if we want to find his speed in miles per hour, we want to take our miles, 2 and 2/3, and divide it by the number of hours, which in this case is 1/2. So do 2 and 2/3 divided by a half. You could also write it as 2 and 2/3 over a half. This is going to get us 5 and 1/3 miles per hour. Now, if your calculator gives you 16/3, I would just convert that into a mixed number, just because that's a little bit more useful in this case to know that it's about like 5.3 miles per hour instead of 16/3 miles per hour. But in this case, yeah, what we would want to do is we would want to figure out how many times 3 goes into 16, which is 5 times to get us 15. We get a remainder of 1, so it's 5 and 1/3. So again, it's really helpful to keep it as a mixed number sometimes. It just depends on the situation. Number 32, a train traveled 495 miles in 6 3/5 hours. What is the speed of the train? So we want to take the number of miles again, 495, and divide it by the number of hours. Remember, order matters. We want to find the speed, which is miles per hour. So take 495 divided by 6 3/5. I like to put the labels on there so I know that it's miles per hour. Otherwise, if I do it in the wrong order, I'll notice that I get hours per mile, which doesn't make a lot of sense. When we divide here, we get a nice round number, in this case, 75 miles per hour. Most times it'll work out pretty nicely for us. No, number 31, it didn't, but a lot of times when you're running, my GPS watch, or if you have an Apple Watch, for example, You can set it so it will tell you your speed that you're walking or running or jogging or whatever you may be doing, and it will give you decimal values, usually not fractions. So normally in real life you would see those as decimals, like on a treadmill, for example. All right, let's move ahead to number 33. Marcus has a bag of cat food that contains 22.5 cups. If he feeds his cats a total of 3/4 cup of food per day, how many days will the bag last? So we saw problems like this back in our fraction unit. We want to take the amount of cups of cat food that are in the bag, the 22.5 cups, and divide it by the amount given per day. We saw some questions with like amount of fabric you have and how much is needed for each uniform, for example, back in our fraction unit. So we saw questions pretty similar to this. Take your total, 22.5 cups, divided by the amount needed for each item, in this case, 3/4 cup per day, and that's going to get you 30. That will get you 30 days. And this makes sense for us because if you're feeding the cat less than a cup of food per day, it should take more than the 22.5 days to consume this food. All right, number 34. Brandon is making pillows for his couch. He bought 4.5 yards of fabric. His total cost was $36. What was the cost per yard? So if we want to find the cost per yard, take the cost, $36, and divide it by the amount of yards, which in this case is 4.5 yards. So $36 divided by 4.5 yards will get us $8 per yard. Pretty straightforward. All right, number 35, last one of these examples. Over the last 5 3/4 hours, it snowed 10.5 inches. What was the average amount of snowfall per hour? Write your answer as a mixed number. So we just recently, depending on when you're listening to this, had some snow. So a great question for us. We want to find the average amount of snowfall per hour. Take your amount of snowfall, 10.5 inches, divide it by the number of hours. Again, we want to be very careful what order we divide in, because we want to find how many inches per hour. So we'll take 10.5 inches divided by 5 3/4 hours. If I remember correctly, we get a pretty nasty fraction here. We get 1 and 19/23 inches per hour. So if a meteorologist, for example, or a weather person were going to report on this, they'd probably say there's about 2 inches per hour falling. They're probably not going to say 1 and 19/23 inches per hour, but it's pretty darn close to 2 inches per hour. All right, so the last thing we want to talk about is writing percents as fractions in simplest form. So in our next unit, we're going to be working a lot with percentages. This is one way to write a fraction in simplest form. It involves complex fractions, and since we can use our calculators, it's pretty helpful here. So if we recognize that fraction or percentages, sorry, compare a number to 100. So if you get a 92% on a test, it's really a 92 out of 100. We can write our percentage as a number over 100. So in example 1, if I have 33 1/3%, and I want to write that as a fraction in simplest form, and I know some of you are thinking, well, isn't that just a third? Well, it actually is, but that's not going to always be the case. Like in our example 2, we can't just take the fractional part of that. So 33 1/3% as a fraction simplest form means writing 33 1/3 over 100. And then we can take 33 1/3 divided by 100, and that will get us 1/3. So 33 1/3% is equivalent to the fraction 1/3. Sometimes I have students who say, well, it's already a fraction. I'll just take the percent off of there. That doesn't work. 33 1/3% is not equal to 33 1/3. In example 2, we have 4.5% as a fraction in simplest form. So we can write 4.5 over 100, which is 4 1/2 divided by 100, which is 9/200. Again, we can divide to find our solution. We just need to recognize that we compare it to 100. So 4.5% is equivalent to 9 out of 200, not 4.5. So be careful, because I often will have students who are like, well, 4.5 is 9.5, so 4.5% is 9 over 2. That's not true. 4.5% is much lower than that. It's 9 out of 200. All right, let's take a look at number 36. So if I have 3 1/3% and I want to write that as a fraction in simplest form, just put 3 1/3 over 100, and then take 3 1/3 divided by 100 will get us 1/30. The reason why we write it over 100 is so we can simplify it. What about 12.5%? We write 12.5 over 100, Take 12.5 divided by 100. We get 1/8. This is actually a fraction that I wanted you to remember or memorize back when we did some fractions and stuff earlier this year. 12.5% is 0.125. It's 12.5%, which is equivalent to the decimal 0.125, and 0.125 is 1/8. We talked about the eighths quite a bit back in a previous unit. Number 38, we have 10 and 2/3%. So write 10 and 2/3 over 100. Take 10 and 2/3 divided by 100, and this will get us 8/75. So you probably don't have the first or the third memorized, but the one in the middle will actually be converting between fractions, decimals, and percents in a later unit. We'll talk about these things again, so we will come back and refresh our memories on this. I know this unit and this lesson especially itself has a lot of little concepts in it, but we'll continue to reinforce them throughout the remainder of the unit as well. Thanks for listening.